Hello students, I hope you all are keeping well and you must be studying very well, right? So in the previous session what we have discussed was regarding uniform motion, and there we discussed the position time graph, the velocity time graph, and we have also discussed numerous numericals based on finding the velocity by position time graph or finding the displacement covered by the body by velocity time graph, right? So today I will devote this session to the topic of non-uniform motion. Now students, uniform motion means a body covering equal distances or equal displacements in equal intervals of time, howsoever small the time interval may be, right? That was the case of uniform motion. When the velocity remains constant, it is only then the body can possess uniform motion. So what about non-uniform motion then? Just think of an example. You go to a market with the help of a vehicle. It can be a two-wheeler, four-wheeler, anything. So when you are on the road, then can you think it is possible for you to maintain constant speed while flying over the road? It's obviously not possible. When you are driving a vehicle on a road, then obviously the velocity of the vehicle must be random. When you see a crowded place or you see a speed breaker, you will definitely apply brake. So the speed of your vehicle will decrease. And if you see a place which is less crowded or the road is totally empty, there's no one, then you accelerate the vehicle so that now the vehicle starts moving with a greater speed. So there, while moving on a road, with the help of your vehicle, the speed of the vehicle do not remain constant. It either increases or it decreases. It might increase or decrease at a constant rate or at a varying rate. So as a result, what happens is, in this case, your vehicle cannot cover equal displacements in equal intervals of time. Actually, your vehicle will now cover unequal displacements in equal intervals of time. And it is in this case that the body is said to possess non-uniform motion. So for a non-uniform motion, the body should move randomly. That is, it shouldn't move with a constant velocity, isn't it? So whenever a body covers unequal displacements in equal intervals of time, then the body is said to possess non-uniform motion. And the most important point to be remembered or noted down is that while in the case of uniform motion, the velocity of the body remains constant. Velocity, remember, it's a vector quantity. It is having magnitude, direction. So when I say velocity remains constant means its magnitude and velocity both should remain constant so as to have uniform motion. While on the other hand, as just now we have discussed, in the case of a non-uniform motion, the velocity is not constant. It varies. Now velocity, being a vector quantity, possesses two parts. One is the magnitude, the other one is the direction. So in order to change velocity, either magnitude or direction or both can be changed. So even if the magnitude of the velocity changes or the direction of the motion of the body changes or both changes, magnitude as well as direction, then the body is said to have non-uniform motion. Right students? So again I repeat, whenever a vehicle is on the road and is moving, then it must be in random motion. That is, its velocity keeps changing either at a constant rate or at a variable rate. So as a result, the vehicle covers unequal displacements in equal intervals of time. When the vehicle speeds up, it accelerates, then it will cover large distance in a given interval time. And on applying brake, it will cover lesser distance in the same interval of time, isn't it? So the body, in this case, will cover unequal displacements in equal intervals of time. That is when the body is said to be in non-uniform motion. So the mandatory condition for a body to be in non-uniform motion is that its velocity should always change. The velocity can't be constant. And students, to change velocity, we have got three options. Either the magnitude of the velocity of the body gets changed, or the direction of motion of the body is changed, or both can be changed. Right? So before we start with the further classification of non-uniform motion, we need to be aware of the term acceleration. Acceleration, retardation, various cases involved, right? Then only we'll be able to understand properly uniformly accelerated motion and non-uniformly accelerated motion. So uniform motion, non-uniform motion can be broadly further classified into these two types. One is uniformly accelerated motion, non-uniformly accelerated motion. But before discussing this topic, we need to be aware of this term, acceleration. So let's start with this particular topic, acceleration. Acceleration literally means to speed up, to accelerate, right? To speed up, to increase the speed. But here, it can also refer to the decrease in speed as well. So that is the case when acceleration is negative. So let's begin with this particular topic. So a body is said to be in accelerated motion when its velocity changes. Now, change in any physical quantity means final value minus initial value of that particular physical quantity. So, when I say change in velocity per unit time, that is, change in velocity means final velocity minus initial velocity divided by the time during which that change in the velocity has taken place. So, students, acceleration means the change in the velocity per unit time, or the change in the velocity of the body with each unit of time. That is known as acceleration. So acceleration basically is defined as the time rate change in the velocity. It is defined as the time rate change in the velocity of the body. Okay. Time rate change means the change in the velocity per unit time. Right? So it is basically change in velocity of the body divided by time. Which time I am talking about? The time during which the velocity of the body has changed from its initial value to final value. And always remember, students, when I mention change in any physical quantity, change means final value minus initial value. So, throughout mechanics, we will be using some notations. U will be the initial velocity, V will be assumed to be the final velocity. So these are the notations I will be using. So change in velocity would be final velocity minus initial velocity divided by the time taken during which the body has changed its velocity from initial value to final value. So remember, from now onwards, final velocity will always be denoted by the notation V. V stands for final velocity of the body. Minus initial velocity will be denoted by U. Time will be represented by T. So, in one-dimensional motion, when we are not considering the change in the direction. In one-dimensional motion means we are considering the body to moving along a straight path. So, the initial and final velocity will be in the same direction. So no need to apply any vectors, right? So you can write it in the scalar form. Although acceleration is a vector quantity, still, since its direction is same as that of the direction of motion, so we can avoid putting vector over here. We are dealing with one-dimensional case. So this is the mathematical expression for acceleration. So students, here U is the initial velocity of the body, V is the final velocity of the body, T is the time during which the body has changed its velocity from U to V. So, acceleration of body is defined as the time rate change in the velocity of the body. That is, the change in the velocity of the body per unit time is known as its acceleration. So, mathematically, A is equal to V minus U by T. Now, let's consider some special cases. Okay, let's consider first case. When V is equal to E is equal to constant. It means that if we consider body moving along a straight path, as usual we are dealing with one-dimensional case only. In that case, if the speed of the body remains constant, with the passage of time, the speed doesn't change, the velocity remains constant. So, that is the case when V equals to U is equal to constant. That is, in case of velocity is constant only in case of uniform motion. We are dealing with uniform motion in special case 1. When V is equal to U, that is velocity is constant, then acceleration will be equal to V minus V by T, which will be equal to 0 by T. That is, acceleration will be equal to 0. So students, when the acceleration of body is 0, when the body is in uniform motion. So when the body is in uniform motion, its velocity is constant. Therefore, there won't be any change in the velocity, and therefore the acceleration of the body is 0. So this is first case, right? Case 2. If V is greater than U, then V minus U would be greater than 0. That is, V minus U is positive. If V is greater than U, then the difference of V minus U would be positive. Therefore, A is positive. Right? If with the passage of time, per unit time, with the speed of the body increases, then the acceleration is always positive. A positive signifies the fact that the speed of the body is increasing per unit time. That is when A is positive. That is when you speed up a vehicle. So the speed per unit time will keep on increasing. Third, if V is less than U. Now if V is less than U, then obviously V minus U would be less than 0. That is, V minus U is negative. If the numerator is negative, then implies that A is negative. It means that when you apply brakes to a vehicle, to a running vehicle, then what happens? Its speed will gradually slow down and eventually the body will come to rest. So A negative means when the body is at slowing down and eventually the body will come to rest. So therefore, in this case, A is negative. It means that it is the case of retardation. It means that it is the case of retardation. Retardation also is known as deceleration. It is also known as deceleration. Clear? Again I am repeating. A can be 0 only when V is equal to U. That is, when the velocity is constant, then acceleration is 0. Second, when V is greater than U, then A is positive. It means that in this case the body is speeding up. That is, its speed is increasing with each unit of time. And when V is less than U, then A is negative. That is, it is the situation of applying brakes, that is slowing down of a body per unit time. So in this case, the velocity of the body will keep on decreasing and eventually and finally the body can come to rest. So when the case arises that A is negative, then it is known as the case of retardation or it is known as deceleration. Retardation or deceleration. Right? So this was about acceleration. So whenever the velocity of a body changes, then the body is said to possess acceleration. And acceleration is defined as the time rate change in the velocity of the body. The time rate change in the velocity of the body is known as acceleration. Clear? Now we can come to these particular topics. Uniformly accelerated motion and then non-uniformly accelerated motion. In the case of uniformly accelerated motion, A is constant. Acceleration is constant. While in the case of non-uniformly accelerated motion, A is not constant. It varies. A is not constant, that is, it varies. This is the basic difference between uniformly accelerated motion and non-uniformly accelerated motion. So we'll discuss. Now we are in a position to discuss uniformly accelerated motion and non-uniformly accelerated motion, right? So both uniformly accelerated motion and non-uniformly accelerated motion belongs to this main topic of non-uniform motion. Both refers to non-uniform motion. In one case, the velocity changes at a constant rate. That is uniformly accelerated motion. And if in a non-uniform motion, the velocity of the body changes at a varying rate, the velocity changes randomly, then it is the case of non-uniformly accelerated motion. Clear? And as I told you, in order that the velocity changes, either its magnitude or the direction of motion or both should change. Either magnitude, velocity or both should change, right? So velocity is a vector quantity. Here we are dealing with one-dimensional case. So uniformly accelerated motion can further be categorized into two types. When A is having constant positive value and when A is having constant negative value. So if A is having constant positive value, then the speed of the body increases at a constant rate. That is known as uniformly accelerated motion. And if A is having constant negative value, then the body is said to have uniformly decelerated motion. So here it can be further divided into two cases. A has constant positive value and over here A has constant negative value. Here it is known as uniformly accelerated motion. Here the velocity of the body increases at a constant rate. It increases at a constant rate. Here the velocity of the body decreases. I told you earlier, A negative means it is the case of deceleration or retardation. So it is decreasing or decreases at a constant rate. So this is the key, constant rate. In both cases, A is constant. But in this case, A is having positive constant value. In the second case, A is having constant negative value. If it possesses constant positive value, it means that the velocity of the body is increasing at a constant rate. And if A is having constant negative value, it means that the velocity of the body is decreasing at a constant rate. So it is the case of uniformly accelerated motion, it is the case of uniformly decelerated or uniformly retarded motion. Both are case of accelerated motion, which in turn is the case of non-uniform motion. Clear? While on the other hand, non-uniformly accelerated motion. Here, A is not constant, that is, A is variable. A is variable means the body is changing its velocity, but not at a constant rate. I'll give you an example, right? I'll give you an example. Suppose A is having value of plus 2 meter per second square, right? And it's constant, it's not changing with time. So what I mean to say is that, just concentrate on the unit. The body is changing its velocity or increasing its velocity at the rate of 2 meter per second, each unit of time. Each unit of time. So what I mean to say is that, if we consider a body to have an acceleration of plus 2 meter per second square, it means that with each second its velocity increases by 2 meter per second. So in the first second, if its velocity is 2 meter per second, in the second second, its velocity will be 4 meter per second. In the third second, its velocity will be 6 meter per second. In the fourth second, its velocity will be 8 meter per second. In the fifth second, its velocity will be 10 meter per second. So here, the velocity of the body is increasing at a constant rate. So it is the case of uniformly accelerated motion. Now, if we consider A is equal to minus 2 meter per second square, which is assumed to be constant. Suppose the body is initially moving with 10 meter per second. U is the initial velocity, right? After 1 second, the velocity of the body would be 8 meter per second because A is negative. A negative means the velocity of the body is decreasing, and since A is constant, therefore the velocity of the body is decreasing at a constant rate. So if initially the velocity of the body is 10 meter per second, after 1 second the velocity of the body would be 8 meter per second. After 2 seconds, its velocity would be 6 meter per second. After 3 seconds, its velocity would further decrease to 4 meter per second. Is it clear? After 4 seconds, its velocity will still further decrease to 2 meter per second. And eventually after t equals to 5 seconds, its final velocity will become 0, indicating that the body has eventually come to rest. So understood both the cases. Here also the velocity is changing at a constant rate. Here also the velocity is changing at a constant rate. But here velocity is increasing at a constant rate. Here the velocity of body is decreasing at a constant rate. So that's uniformly accelerated motion for you. While in this case, suppose acceleration is variable. The first and foremost it is 1 meter per second square. In the second case, initially at t equals to 1 second, at t equals to 2 seconds, acceleration is minus 2 meter per second square. At t equals to 3 seconds, acceleration is plus 4 meter per second square. Understood now? So here, with each unit of time, the acceleration is not constant. It can either increase or decrease, but it is not constant. When acceleration is not constant, it means that velocity of the body is changing, but not at a constant rate. That is when the body is said to possess non-uniformly accelerated motion. Clear? So students, basically, if you are dealing with the case of uniformly accelerated motion, in this case, the acceleration of the body must be constant. It can either have positive value or negative value, but its value should be constant, indicating that the velocity of the body is increasing or decreasing at a constant rate. While on the other hand, if we are dealing with non-uniformly accelerated motion, it clearly suggests that the velocity of the body is changing, but not at a constant rate. So that's the basic difference between uniformly accelerated motion and non-uniformly accelerated motion. We will discuss the graphical study in the next session. We will discuss the position time graph, as well as we will discuss the velocity time graph, and obviously we will discuss the importance of those graphs as well. But first, go through this theoretical topic in detail, and thereafter only you will be able to understand the next subsequent topics. Till then, do take very good care of yourself and do study very well.